Welcome to this lesson on trigonal planar molecular geometry. Today, we're going to explore one of the fundamental shapes that molecules can take, characterized by its distinctive 120-degree bond angles. This flat, triangular arrangement is crucial in understanding how atoms bond together in chemistry. Trigonal planar is a specific molecular geometry where three atoms arrange themselves around a central atom in a flat, triangular shape. The key word here is flat, meaning all four atoms lie in the same plane. This creates three bonds extending outward from the center, with 120-degree angles between each pair of bonds, forming a perfect equilateral triangle. This geometry comes from VSEPR theory, which stands for valence shell electron pair repulsion theory. The fundamental principle is simple. Electron pairs around an atom repel each other and naturally spread out as far as possible to minimize repulsion. When three bonding pairs are present with no lone pairs, they naturally adopt the trigonal planar arrangement to achieve maximum separation. The 120-degree bond angle is not arbitrary. It represents the maximum possible separation that three bonding pairs can achieve when confined to a single flat plane. If you imagine dividing a full 360-degree circle into three equal parts, you get exactly 120 degrees. This equal spacing minimizes electron repulsion and creates the most stable molecular structure. For a molecule to have trigonal planar geometry, two critical requirements must be met. First, there must be exactly three bonding regions, meaning three atoms bonded to the central atom. Second, there must be zero lone pairs of electrons on the central atom. If either condition is not met, the molecule will adopt a different geometry. Let's look at three classic examples of trigonal planar molecules. Boron trifluoride, BF3, is perhaps the most common example, where boron is the central atom bonded to three fluorine atoms. Sulfur trioxide, SO3, has sulfur at the center with three oxygen atoms. The carbonate ion, CO₃², features a carbon atom bonded to three oxygen atoms and carries a -2 charge. Taking a closer look at boron trifluoride, BF3, we see boron as the central atom. Boron has three valence electrons and forms three bonds with three fluorine atoms. With no lone pairs remaining on the boron, the molecule perfectly satisfies the requirements for trigonal planar geometry, creating a flat triangle with 120-degree angles between all fluorine atoms. Let's summarize what we've learned. Trigonal planar molecules have a flat triangular geometry where all atoms lie in the same plane. The bond angles are always 120 degrees between all three bonds, providing maximum separation. This geometry requires exactly three bonding pairs and zero lone pairs on the central atom. Understanding this shape is essential for predicting molecular properties and chemical behavior.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.